Friction is the force caused by two surfaces sliding past each other. It's dependent on the normal force between the surfaces and the coefficient mu. The force of friction is always in the direction parallel to the surfaces in contact. Or, force of friction equals mu n. Static friction is two surfaces that are interlocked and have no motion. Kinetic friction is between two surfaces that are sliding or dynamic. The differences between static and kinetic friction can be seen on the micro level. Friction is caused by individual normal forces between the microscopic discrepancies in objects. Static friction exists when microscopic surfaces remain interlocked, and remains until enough force is placed on the objects to break the connections between the microscopic surfaces. The above equation is modified to f of s is less than or equal to mu s n. Kinetic friction is caused by the microscopic hills and valleys continually hitting one another but not settling back into an interlocking structure, or static friction. One surface bounces along the discrepancies in the other. The equation is modified to force of kinetic friction equals mu kn. However, this force is lower than the force required to break the surfaces from static friction, and thus the coefficient of static friction is greater than the coefficient of kinetic friction. Let's do a sample problem. A man is pushing with some constant force on a 50-kilogram box at rest on a table. The coefficient of static friction is 0.7, and the coefficient of kinetic friction is 0.5. The first step in solving any friction problem is to make a free body diagram and label your coordinate axes. From there, you can use Newton's laws to solve for force in the x direction, or force is equal to the force of friction. Next, we solve Newton's laws in the y direction, and we find out that the normal force is equal to the force of gravity. Next, we will solve for the force of static friction, which is less than or equal to mu s n. But in this case, we are solving for the maximum possible force. So this force is going to be equal to mu s n, or force of static friction is equal to mu s mg. Next, plug in your equation and solve, and we find that the force that this man is pushing at is 343 newtons. In the second half of the problem, we do the same thing as we did before. We take the force of kinetic friction, which is equal to mu kn, and we substitute in for the normal force. So force of kinetic friction is equal to mu k mg. We then plug in and solve, and find that this man has to push at least 245 newtons to keep the object in kinetic friction.